Hey everyone, today we are going to solve the Daily LeetCode challenge of 9th March 2024 and the problem statement is minimum common value. So let us first understand the problem statement. So according to the problem, we have been given two integer array nums1 and nums2 such that both of them are sorted in non-descending order. Okay. And what we have to return is the minimum common value. Now what do I mean by that? If I have nums1 and we have nums2, so let us find out that what are their common values first. Okay. So we can see that we have 4 in nums1 as well as in nums2. Then we have 6 in nums1 as well as in nums2. And then we have 8 in nums1 as well as in nums2. So these three, that is 4, 6, 8, are the common values in nums1 as well as in nums2. But what we have to return is the minimum of these common value, right? So what is the minimum of 4, 6, 8? The minimum of these are 4. So 4 would be our answer. So now let us see how are we going to solve this problem. So I'll be discussing two approaches for solving this problem. Let us now first discuss the approach 1. So what we will do in approach 1 is, we'll take a hash map and we can iterate over this nums1, and what we will do is we will store each of the values of nums1 in the hash map, and corresponding to it we will just store its frequency. Okay, so what we will store is the element and its frequency. Okay, so first of all, we would be here at 1. So what we will store is 1 and its corresponding frequency would be 1. Then we will move to 2. Then its corresponding frequency would be 1. Then we will move to 4. Its corresponding frequency would be 1. Then we will move to 6 and its corresponding frequency would be 1. Then we'll move to 8 and its corresponding frequency would be 1. Then again we'll move. Now we can see that we have completely iterated over nums1 and we have populated this hash map. Now, what is the second step? The second step is to iterate over nums2 and to check that whether these elements are present in the hash map or not. Okay, so what was our first step? First step was populate hash map using nums1. Okay, we were using the values of nums1 to populate the hash map. After that, what we will do? We will iterate over nums2 to check if the value is present in hash map or not. If the value is present in the hash map. Now, the moment we'll get a value which is present in the hash map, then what does it mean? It means that that particular value is common to both nums1 as well as to nums2, right? And another thing is that that's the minimum common value as well, because the value which we will get in common at the very first, that would only be the minimum value. Why? Because both the arrays are sorted, correct? So let's see what we are going to do. So currently our pointer would be at this 4. So we will check that is this 4 present in the hash map or not. So we can see that 4 is present in the hash map, which means that this 4 is common to nums1 as well as to nums2. And since this is the very first value which we are able to find in the hash map, then what does it mean? It means that it is the minimum common value. So we'll simply return 4 as the answer from here. Okay. So I hope this is clear. Now let's quickly code this. So we will start on by creating an unordered map. Its type would be int, int. What we will be storing is the element and its corresponding frequency. So let us first populate this hash map. So we will be populating the hash map using the elements of nums1. So we can say that memo of current plus plus. Now, once we have populated the hash map, what we have to do is we have to iterate over the nums2, right? To check whether the value is present or not. So what we will do here, we will say that for auto current is to nums2, if this current is present, now what does this mean? It means that if this current is present in a nums1 as well, right? If it is present in this hash map, then what does it mean? It means that it's present in nums1 as well. It means that it's the minimum common value. So what are we going to do? We are simply going to return current from here. Otherwise, here it is written that if there is no common integer to both num1 and nums2, then what are we going to return? We are going to return a -1. So what we will be returning from here? We will be returning -1. Now let us run this code. So it is giving the correct answer. Let's submit it. So it got accepted. Talking about the time complexity and space complexity. So if we consider the size of nums1 as m and the size of nums2 as n, then the total time complexity would be order of m plus n. Reason is that here you can see that we are iterating over the complete nums1 to populate the hash map. So what is this going to cost? This is going to cost us a time complexity of order of m, because we are having total m elements in nums1, so we will be iterating over each of these m elements, correct? Additionally, here you can see that we are iterating over nums2. Okay, now in the worst case scenario, what could be possible? That nums1 and nums2 are not having any elements in common. So in that particular case, we have to traverse the entire nums2 to check for the common value, right? So in the worst case, we are going to have a time complexity of order of n over here. So the total time complexity would be order of m plus order of n, correct? And the space complexity is order of n. Why? Because we can have nums1 like this, in which all the elements are distinct. Then there would be total of m entries in the hash map. Therefore, the space complexity would be order of m. Now, let's see how are we going to solve this problem using a second approach. Now, as you all saw that in the previous example, we were using a hash map, which was costing a space complexity of order of m. So in this second approach, what we are going to do is we are going to use the space efficiently. That is, we are going to solve this problem using a space complexity of order of 1. So let's see how we can do it. So we are going to use 2 pointers. Say, for example, this is I and this is j. And what we will do is we will iterate over nums1 and nums2. And the moment we will get nums of I, nums1 of I equals to nums2 of j. So what does it mean? It means that we have got the minimum common value. So what we will return? We will simply return this particular value, that is nums1 of I. You can also return nums2 of j because both the values are same. So it doesn't matter whether you return nums1 of I or nums2 of j, correct? Now, what would be the second condition? The second condition could be that our nums1 of I is lesser than nums2 of j. Then in that case, what we will do? See, if our current value of nums1 is less than the current value of nums2, then irrespective of how many values we check in nums2, right, we are not going to find any value which would be equals to this nums1 of I. Why? Because nums2 is sorted. Say, for example, if here my I is at 1 and our j is at 4. So here you can see that 1 is lesser than 4. So it doesn't matter that if we increment the j pointer to the next element and if we iterate over the entire nums2 to find this 1, we are not going to find it in nums2. Why? Because since this 1 is lesser than 4, so it is obvious that this 1 would be lesser than all the values which are present at the right side of 4, because this array is sorted. Okay. So whenever we'll get that nums1 of I is lesser than nums2 of j, so what we will do? We'll simply increment the ith pointer. Why? Because there is no way that we are going to find this 1 in this nums2, because this 1 is lesser than 4. So all the elements in the right side of 4 would be obviously greater than this one. Okay. Now what could be the third case? The third case could be that nums1 of I is greater than nums2 of j. So if nums2 of j is lesser, then what does it mean? It means that irrespective of how many values we check towards the right side of this I, we are never going to get this particular value, that is nums2 of j, right? Because nums1 is also in sorted manner. So what we'll do, we will increment the jth pointer in that case. Okay. So let us do a quick diagram to understand this in a better way. Okay. Here is our ith pointer and here is our jth pointer. Now we will check these three conditions. So is nums of I equals to nums of j. So in nums of I, what we are having? Let me write nums1 of I, and let me write here nums2 of j. So in nums1 of I, what we have is 1. In nums2 of j, what we have is 2. Are these two equal? No. So the first condition didn't hold. Is this first value lesser than the second value? So yeah, you can see that 1 is lesser than 4. So what we will do, we will increment the ith pointer. So now our ith pointer is pointing at 2. So now we have 2 over here and we have 4 over here. Now again we'll check for the first case, that are these two values equal? No. Now we'll check for the second case, that is nums1 of I is lesser than nums2 of j. So we can see that nums1 of I is lesser than nums2 of j. So what we will do, again we will increment the ith pointer. Okay. Now we are having 4 over here and we are having 4 over here. Again we'll check for the first case. Is nums1 of I equals to nums2 of j. So here we can see that 4 is equal to 4. Okay. So our first condition holds. So what we will do is simply return 4 from here. So we will return 4 and 4 is our answer. So now let's quickly code this. So first of all, let us take 2 pointer I and j. Initially, both of them would be 0. And what we are going to do until our I is less than nums dot nums1 dot size, and then j is less than nums2 dot size. What we are going to do is we are going to check for the first condition that if nums1 of I is equals to nums2 of j, in that particular case, what we will do? It means that we have got a minimum common value, so we are going to return nums1 of I. Okay. Otherwise, what could be possible? Otherwise, our nums1 of I could be lesser than nums2 of j, correct? So in that case, what we will do, we will increment the ith pointer. We saw over here that what we were going to do in that case, we are going to increment the ith pointer. And what would be the third case? The third case would be that our nums1 of I is greater than nums2 of j, correct? So in that particular case, what are we going to do? We are simply going to increment the jth pointer. So if we'll get a minimum common value, it will get returned from over here. But if we don't get a minimum common value, then in that particular case, what we have to return is -1. So what we will be returning from here is -1. Now let's run this. So it's giving us the correct answer. Let's submit it. So it got accepted. Now talking about the time complexity and space complexity. So if we have m as the size of nums1 and n as the size of nums2, then in that particular case, the time complexity would be order of m plus n. Why? Because here you can see that what we are doing, we are iterating over all the elements of nums1 and all the elements of nums2. So in the worst case, what could be possible? That both of them are having common values at the very end. So in that particular case, we are going to iterate over both the arrays completely. So it is going to cost us a time complexity of order of m plus n. And the space complexity would be order of 1 because we are not using any extra space from our end. So that's all about today's Daily LeetCode challenge. Thank you.